All right, thank you so much to the organizers for having me here at this event, and thank you all for coming, and I hope to share my ideas with you and hear some feedback from you as well. And my topic today is blockchain banking. I'm Houman Shadab, professor of law at New York Law School. My research focuses on financial law and regulation, increasingly so on fintech, including, of course, our friends, blockchains, Bitcoin, and so forth. So basically my talk will be about data. Ultimately, I felt that if I'm really going to understand what's going on in this area of blockchains and banking, unfortunately, I had to really push myself and learn new stuff in this new area of data structures, data processes, data architecture, all these fun words that are relatively interesting and new to me, and I think ultimately certainly have legal implications, certainly structural and contractual ones as well. So I'll take a sort of step back and think about what's going on in data in the world, and I think we all know it's sort of companies, whether it's banks, corporates, hospitals, whatever it is, nonprofits are going from sort of paper-based and manual processes to automated ones, the ones that are digitized. And for that, you need to think about what is data exactly, how do we format it, how do we enter it, how do we capture it, do we scan it, is it just sent across some sort of processing system? There's a lot of talk about reference data. How are dates and names and numbers just kept consistent across records over time? That's a big issue. Of course, how is data managed? And from that, we have enterprise data management platforms of a wide variety, just to keep the data consistent, perhaps over time, and to send the data where it needs to get when it needs to get there. Business logic, okay, combining just abstract data types and so forth with actual commercial uses and entities, and profit centers and profit logic, and that's sort of where the rules engines come into play, and that's why I think our discussion and people's discussions about smart contracts sort of fit into that as well. And system access, okay, so we have data wherever it's located, maybe on a central server, maybe on a distributed ledger, wherever it is, and then who has access to that? Is it on some level the public? Is it a very small group of people? And what does it take to get access? Is it through some type of web terminal, like a REST system, repositional state transfer technology? Is it through some type of remote procedure call? So how do we get access to that data is another basic concern. And certainly workflows. How are workflows managed when things become complex, when they use wide variety of individuals across different organizations? And all this will sort of dovetail when I get into, well, what does this have to do with the blockchain, as we sort of keep these ideas in the background, then apply it to finance, and in particular, I'll finish off with the example of bond trading and reporting, right? And this most likely goes to regulatory requirements, but everything from keeping data, keeping it high quality, consistent over time, to how do you report it, how do you display it, tools including dashboard displays, warehousing, and so forth. That's just a very broad picture view of data, but here is one example from the classic example from the commercial finance world, which is illegible here, but this is a representation of a letter of credit. Okay, not a paper-based letter of credit, but one that's electronic to some extent, is SWIFT coded, and basically it's a sale of barite ore from Mobway Minerals to Baker Hughes, which is a Texas-based energy firm. And the basic idea here is that it's in accordance with the SWIFT messaging system, which is itself, SWIFT is not a transfer network, it's not a settlement protocol or anything, it's just a way to consistently code financial and financial-related business messages among entities in a uniform way. And here, basically, the idea is buyer, seller, JP Morgan's the bank, what's being delivered exactly, where does it be delivered, where are the ports that it takes off from, where is it supposed to land, what exact quality of the good, and if all the conditions are met in a typical letter of credit, then the capital will be released to the seller, and the transaction will go through. Otherwise, without the proper conditions being met, basically the seller doesn't trust the credit of the buyer, so the buyer has to apply for the letter of credit there. And point being there, even some sort of basic commercial or the international transactions, data can already be brought into play, and we can think of those basic ideas about how is this data captured, how is it organized, what are the workflows involved with that. part of that, I think, also was maybe mentioned earlier on the panel, was business process management. So things going from manual and paper-based to being automated and digitized. Then once you have that, you can have another level of analysis or analytics being performed on things that previously were not able to be analyzed in any rigorous fashion, not to mention certainly not analyzed with machines, with software, or anything like that. And if you look at over time, I'll just give a bunch of financial examples as I go along, moving from paper-based, crude uses of checks, if you will, to at least scanning checks in and making them digitized, having the fields of signature, payor, payee, the amount, and the date, and so forth, allowing banks to obviously save on operational costs and times, probably reducing errors in the workflow as well. And once they do that, then they're able to monitor how their checks are processed, how the resources are being used, and make higher level forms of engagement with either their customers or achieve second level and secondary operational efficiencies from there. Also in the financial realm, there's something called straight-through processing, which basically says once in any area a trade begins, it's basically automated until it's complete, until the final legal obligations are extinguished, known as settlement. And that's sort of, in many respects, routine in some areas, like FX and certain aspects of payments that are maybe, for example, domestic payments are largely STP because they're just settled in a real-time gross basis. But in other areas, we still have, even in finance, in the 21st century, there's still many areas that are still very much paper-based, including bond trading and issuance, including mortgage lending as well, specialized lending and underwriting aspects of those. And finally, just sort of what's your business process management looking like, automation, bringing new products in, and improving existing practices, all of which I think that if you keep these ideas in the background, think about what a blockchain can or maybe can't do for financials, I think that is really going to help people say, why are we designing this blockchain in any case? What are we trying to improve on that the existing softwares and technologies can't do? And as we move away from like the open blockchain of Bitcoin more towards specialized commercial or financial applications, you want to say, well, now you're getting into the mix of a wide variety of software vendors and others that are also probably trying to do something similar to what blockchains are doing. So keeping these broader business goals, procedures, and considerations in mind, I think is important. Okay, so a related development, I think, when we think about automation, which is a large part of where the world is going in many respects, automating lawyers, medical professionals, and so forth, is part of that, I think, a background aspect of is computational contracting. So there's a really great paper by Goodenough and Flood, just published this year, really a working paper of the United States Department of Treasury's Office of Financial Research, OFR, really coming from the top levels of the US government, basically talking about how to, first of all, arguing that contracts are a primitive form of code, primitive form of computation in the very primitive sense perhaps of computation known as formalized state transition systems, or a type of which is deterministic finite automation. And the basic idea there is that for any given event that happens, there's a deterministic outcome. Okay, so you default in your loan, there's basically a deterministic outcome about what the consequences of those are, or at least a finite range of them. And the basic rule for this form of approach to developing software is to keep things such that any change in a relationship as things go forward have to be fully captured by the current state now. All sort of future events need to be laid out in some deterministic fashion. I think it's a benefit from a automation or maybe a smart contracting point of view because it prevents maybe infinite loops from happening, or prevents maybe an unreasonable size of memory and processing power from being used. If you just have a finite state of, think of a simple loan, things that can happen. Either you pay in the loan, or you defaulted, or something in between then has happened. All these things we specify ahead of time. And part of that is going from natural language contracting to data-oriented contracts. There's a good paper by Surdin on that. And the basic idea there is natural language can be ambiguous, it can be rife with error, and so on and so forth. And how can we improve on that process by really thinking very clearly about what contracts are trying to do between two parties, perhaps more, and then formalizing that business logic into some type of formalistic coding-based relationship. And again, once you do that, then you can automate the processes, have data analytics, not just on the contracts themselves, perhaps even on the certain provisions being used. Maybe certain types of warranties are better to use in some cases than others, and then maybe whole slews of contracts, databases of contracts can be analyzed in a certain way, and they basically come up with this sort of, just to go one more step further into their research, they have this formalistic approach, which just comes from DFA generally, and then they just apply it to contracts. Basically, there's a beginning state, an end state, a finite set of events that happen, a finite set of sort of transition states that can happen. And basically, if you do it right, and it's not necessarily easy, but if you do things right, you can basically, in a sense, program the contractual relationships up front, which in a sense is what a contract tries to do, right? Says that, again, think of a simple loan, or even then we can think of complex financial relationships like derivatives. But think of a simple loan that says, again, we pretty much know what's going to happen. Once you qualify, you get the money, you pay it back plus interest according to the amortization schedule, and that's sort of the happy state. And if you don't, then there's certain consequences, but those consequences are generally, or at least we can generally specify them ahead of time. And so just be a little more formalistic here. We have a certain, at any time there's a relationship, it has to be, the status has to be in one state. Okay, so that's Q is a subset of the large Q, basically all possible states, and what these events are which trigger states sort of map onto this next state after it goes through the processing function is, for example, either you're paying, you don't pay, maybe you're in breach of a technical loan covenant, like your financial ratios are not up to par as you promised they're going to be, or something like a cross default. So that's sort of like an input from an outside, the outside world, in the sense that you've defaulted on not this loan but another loan, but a default on another loan is considered a default on this loan. It's a cross default provision. Okay, so that is, I think, something to keep in mind. Computational aspects of contracting is ultimately blockchains in finance. Again, part of that's automation, and part of that will be automating what? Contractual processes. But distributed processing, so certainly Bitcoin is not the first form of distributed computing. And in banks, okay, distributed computing came about in part to service geographically diverse banking systems, just to say, hey, we need servers in more than one location. And that was helpful because it helped banks to keep or improve to real-time processing as opposed to batch processing overnight and so forth. But the problem with traditional, maybe distributed computing was that it created the need for sort of aggregating lots of data across different servers, across different data centers, banking systems. So what Robert Sams just called this in a really interesting blog post I just recently came across was, in a sense, this form of distributed computing, information is sort of everywhere in that simple sense distributed, also had a consensus mechanism, but it's basically consensus by reconciliation, just saying, hey, one computer says this, one computer says that, maybe a potential borrower talked to a mortgage lender in this office, and then the potential borrower, same borrower talked to a mortgage lender in this office. And they both said quoted different rates for the mortgage, different other aspects of it, so we kind of need to reconcile that to find the one true loan rate, the one binding loan rate for that borrower. If you look at some of the way banks sort of tell their employees on how to act, they say there might be different sources of data everywhere, but go for that and approach it with a sort of golden source data to avoid conflicts, okay? So without what we know is a distributed, replicated shared ledger, you, at least in principle, make it easier to have conflicts with data. So let's take a look at one case study, just one HSBC. Basically, probably not unlike a lot of other very large banks, by 2007, they had a lot going on. 55 core banking systems, 24 credit card systems, 41 internet banking platforms, 130 data centers, or 10,000 branches. So that was just sort of the process of one bank, how it evolved over time, how they probably built system on top of system and iterated at the edges, and definitely the left hand didn't know what the right hand was doing. at any given time. But the HSBC was kind of unique, I believe, because they really tried to be conscious about fixing that, trying to have one core banking system, automate lots of processes, take a customer view of the bank instead of like some kind of system-driven account point of view, and reducing steps, for example, of how, hey, I lost my debit card, what's sort of the next step? And we've all maybe felt the brunt of that on the service end, having, calling companies and banks, not getting sort of live people on the end. But that is probably a bad thing from an architecture point of view of where this bank was in 2007. How about another example, another case study of distributed computing? Well, Salomon Brothers in the late 1980s, okay, what was going on? A lot was going on, but including mortgage-backed securities and asset-backed securities, including mortgage-backed securities, were getting more complicated. So they were just basically impossible to properly price manually. So they had to develop software applications to do that, including the yield book, to model asset-backed securities. Okay, so how is that going to happen? Well, they decided to use a distributed architecture to do that. And the first iteration of this went through 3 phases, basically. The first iteration was just have servers at their clients. Okay, so clients that are going to use these securities, trade them, can also have basically their Salomon Brothers the yield book software at their own offices. Problem with that, though, was data overload. Their servers that were remote or client-side servers just weren't strong enough. So they tried to bring the CPU, some of the major CPU power processing calculations in-house. But that eventually helped, but it also still wasn't enough. So the final distributed software architecture that they settled with, which was basically efficient, at least for that time, for that perspective, was basically removing all the remote servers from them, taken away from their clients, and just having the clients sort of log in remotely, but having all the data back into Salomon Brothers in a centralized way, because ultimately they needed that much computing power to process these securities. Okay, so we can think about how blockchains may improve that, maybe get the benefits of that kind of distributed computing, but maybe not have some of the costs that we saw. So we can think about data architecture, just to basically how do you organize data and these systems together, the relationships, the design principles, what are your design goals? Okay, and let's take a look at cloud computing and banking. The whole purpose of cloud computing is to basically outsource certain, or maybe all of your software uses to the third party, including maintenance, including upgrades, and of course that deals with security issues, accessibility, but to hopefully reduce costs, especially over time for banks. And so banks have had some problems with just going full public cloud for maybe for security reasons, for example, and others. So maybe one middle ground is over private cloud. Okay, that brings sort of the benefits of outsourcing your software to third parties, but having it in a more managed control way. And for example, BBVA in 2012, and there's many examples like this, started using Google Apps internally with thousands of their employees. And lots of people talk about a blockchain, a private blockchain, as in a sense like a private cloud, kind of trying to get the best of both worlds in terms of distributed computing and ledgers and so forth, with also controllability and just the right amount of accessibility too that the banks want. So what are some architectural goals? And you hear this certainly in lots of discussions about Bitcoin versus other blockchains, and including the future of the network. We think about resilience against failures, okay, just sort of operational and technological failures, scalability, okay, that's a big idea, but also a general IT idea is scalability, including scalability and maintaining security properties. Performance, okay, speed and just quality of the performance, and then security in the sense of privacy, perhaps, or security in the sense of against fraud and data quality. And we can think about that as trust as well, I think. Auditability of records and processes, and that comes more into accounting, auditing, regulation certainly as well. How good is a system in adaptability, in maintaining itself, in changing over time, and improving and upgrading as well. How is the geographic distribution? I mean, that certainly matters just from a architectural and processing point of view, and also from a regulatory point of view. Even if you have one ledger, there's not one regulatory system around the world that's going to deal with it in the same way. Of course, what are the costs, and then just general sort of legal and risk management issues for architectural goals. So big blockchain or not, this is what all sort of software and data approaches towards transactions, financial or otherwise, need to sort of think about. Okay, so now let's wrap it down into a blockchain, then we can apply it to a financial transaction. So let's talk about blockchain structure. Is the way I view it is structure, process, architecture. Structure is basically static point in time, how is the data there? And so blockchains are really about a list of value transfers. So blockchains are not trying to capture and list, the data structure is not about just listing data, numbers, words, paragraphs, and so forth. It's about relationships. It's about transferring values, inputs, outputs, from and to, and so forth. And ordered, in the terms of the blockchain, means there's that sequential order. That's what it's about, and that's what they sort of mean by time stamping. Not so much with the actual time of day and week it is, but about the ordered. Any given point in time, you know what sort of transactions came before that, and you have the prior transactions, right? So it's that long block people talk about. In terms of the structure, you see the hash of a block after the performed from the hashing function, and then you see the previous block as well. So just part of the structure, again, of, I think, a blockchain transaction. I'm mostly going off the Bitcoin blockchain, and there's going to be variations in all this, but it's just the relationships and then the tail moving back on the history of the transactions. And then, of course, I think another important aspect from a static point of view is the wallet. So at any given point in time, what does a wallet have? There's private public key pairs, the inputs and outputs unlock those transactions, sort of make them move across. Okay, process. Well, from a transactional point of view, it's those digital signatures, those private keys that allow you to spend the money, spend the Bitcoin, spend the block, spend the tokens if you have those unspent transaction outputs. But you can also use more than one signature for multi-signature. You can use some kind of script that you send the coins to, so it can get more interesting and perhaps safer as well. And then consensus validation, a lot has been talked about that, but one idea is I view it as Bitcoin being sort of market-based data processing. So if you trust the market and the incentives that are there, then go for it. And also from a design goal perspective, you know, Bitcoin, as was mentioned, in other words, was designed for censorship resistance, the CR there. And if you want censorship resistance, that's probably the way to do it. But it comes with a cost of mining, a cost of maybe pseudo-anonymous nodes, and so forth. Banks probably don't want censorship resistance. That's probably not what they're looking for. So they probably don't need proof of work for that. They're not willing to pay those costs that come along with it. Or you have some form of, you know, centralized is a sort of a bugaboo word. It means a lot of things. Same thing as decentralized. But in any case, if it's not sort of market-based and driven by censorship resistance, anyone can download a node, proof of work, then it's going to be something a little bit else, some sort of permission ledger. And retrieval, okay, so the data is there. How do we get the data? How do we find the transactions? How do we find the public addresses? Well, get an explorer for the blockchain. Okay, so there's Bitcoin explorers out there that let you look up transactions, see them in real time as well. Architectural considerations, the major, I think, way to see Bitcoin or the blockchains is it shared or replicated ledger, where the nodes are decentralized. And of course, different blockchains will be, again, decentralized to different degrees. Maybe not at all in principle, can be. Another architectural consideration I think important is the transaction propagation through the nodes on the network. And basically creating a single network, in other words, a single repository of that data. That's a real value add, I think. And then, you know, consensus-based security, again, based on different types of consensus mechanisms people have talked about, and then some form of probably open source governance, either to the code or to some other aspects of the system, again, probably to varying degrees based on blockchains. Okay, so there's a lot of media reports about all these banks, commercial and investment, getting into blockchains in one form or another. But if you look at blockchains as technology, as a type of data structure, process and architecture, then what are the benefits? Well, all this stuff hopefully will give you better speed, probably from streamlining operations, having a single ledger, and just from automating processes if you can. Cost, improve security and transparency, that's the hope. That's the hope of everybody in every software solution. It's not just a blockchain. And some of the use cases are probably relatively familiar with. Payments and funds transfer is probably the lowest hanging fruit. For example, Ripple going just basically, in principle, taking the need away for intermediate banks, plugging into the existing banking architecture to create a settlement infrastructure, including Ripple. I don't think tries to replace Swift. It actually uses Swift messaging system with its network. Trading financial instruments, maybe other properties or digital representations of them on a blockchain. And part of this is automating the life cycle. As we'll see, there's many steps and potential steps in terms of going back and forth, in terms of trading securities and derivatives and so forth, especially derivatives because they're such long-term contracts, 5 years and so forth. As opposed to security, you can settle that in 3 days and kind of go home. Swap contract, you're sort of on the hook with your counterparty, whether it's a clearinghouse or a purely bilateral one, for a while. Automating that process, okay? So corporate actions, mergers, stock splits and so forth, and that is another process that lots of companies are trying to automate. Trade finance, people have talked about, supply chains, and just general audit, risk management, compliance, regulatory issues by building sort of disclosure requirements, identification requirements, limitations on activities requirements into into code, and sort of programming regulation, if you will, up front in itself, including the transaction structure and the history of the transactions being to whatever extent transparent, maybe publicly transparent, to whatever extent auditable as well. Okay, I just want to take a quick look though. So that's the pitch for a blockchain on some level, and certainly there's a lot more details and a lot more strong arguments that can be made. But what else is going on, just to keep it a little bit of a broader view in the non-blockchain world? Well, not to go, just to put these out here, but there's a lot of software, a lot of platforms, a lot of solution providers, vendors, companies trying to do what I think blockchains are trying to do as well. Perhaps in some ways better, perhaps in some ways not, and I'll just sort of throw the question out there. But a lot of people are trying to automate systems, create single platforms, consolidate data, create interoperability between systems, create more security, create irreversible transaction records. So I think a lot of players in the industry are on the same page, and I think for blockchains, the answer is, again, or blockchain providers, is what can you do that's not already being done? I think in some cases the answer is obvious, because these solutions are not using distributed or shared ledger networks. But what else besides that? Is that a value in of itself? Probably. But I think that you need to be careful about that. Also, sort of just some other examples, what other companies are doing, again, automating these processes all the way through different aspects of the financial markets. And how about in the regulatory world as well? I am a lawyer, so I kind of can't forget about the law. So something called the Clarion Hub was launched just back in, just recently, in March 2015, with the DTCC and several large banks. And basically the idea there is to create some kind of uniform shared facility for client data and documentation to support regulatory requirements. A banker I told about this said, yeah, well, no one's really signing up, it's not really working, it's probably never work, but if this is never going to work, then maybe the question is, maybe that's a good reason to use blockchains, because there are different incentives in trying to get everyone in this area, basically a quasi-utility plus banks on the same page. Or maybe there's the same problem there. Why would any company upgrade their computer systems anyways, blockchain or otherwise? What else is going on in this area, just in terms of software and compliance? Is basically, just here's some examples again, lots of companies trying to automate aspects of regulatory compliance across different fields, whether it's AML or sanctions or the Volcker rule, which is that monstrosity from across the pond that applies to you if you trade with a US bank. So just something to think about there, something to learn from. I think blockchain solution vendors, if you want to just refer to yourself that way. I know it's maybe not as revolutionary as other ways to refer to yourself, but in any case, there's a lot going on in this fintech world that I think is worth paying attention to. Okay, and so we've seen a lot of investment by banks and other financial firms in this area, and corporates, and that's just from a CNBC article recently. I won't read through that, but check it out. And then finally, banks nonetheless, though, so they are investing in blockchains, they see different value, and they're at least experimenting with it. And then there's one idea is, should we use a private blockchain or should we use the Bitcoin blockchain? And there seems to be a somewhat emerging consensus with private blockchains being more controllable, being cheaper, being more efficient to process the data, and certainly being more up to par with legal requirements that banks basically need to comply with, in terms of the anonymity of their counterparties, the anonymity of the transaction validators. And finally, I'll end with securities, trading and settlement. Again, lots of details. If you've ever taken out a mortgage, you know the details that are involved there. Just imagine them even being similar, but even I think more more rigorous and more numerous and more sort of at stake with respect to the trading of the instruments as well when you're trading securities or bonds. Whether it's getting the actual trade right, getting the numbers right, the counterparties, who's the custodian, make sure they have custody, make sure they actually have the security that you said you could trade, the numbers and so forth. A lot of that sort of reconciliation of the numbers, the confirmation of the actual trade, and lots of different sort of intermediaries involved. So in sort of a battle royal right now going on, I just read about UBS making smart bonds. We're not sure exactly what those are, but based on a media report, they're making blockchain-based bonds. And International Financial Review just a few weeks ago, or last week, said basically, just quoting from the article, not really analyzing beyond that, by saying they're going to give you the risk-free interest rate and payment streams in an automated way. Okay, that makes sense. And creating a self-paying instrument. So I assume that the reporter in that article meant it's something like a self-executing instrument that once things are set up somehow, it's self-paying. I'll take one of those. That sounds pretty good. And then what the UBS rep quoted in the article, I think gave a little bit more insight here about basically eliminating, to a large extent, what was in the previous slide, were known as front, middle, and back office distinctions. And sort of, again, in a sense, it seems to me like they're trying to preload a lot of the operational and back-end aspects of bond trading sort of up front. So no middle, back office, and no registry. Apparently no centralized registry. Maybe that's what he's referring to. Something else altogether, and that sounds interesting. Parallel development is something one company, just a company I happen to read about, and I think is a good distinction here, is OpenBondX. So bond trading has historically been not very automated, not very transparent, not very digitized. But OpenBondX is trying to change all that, so it's doing, thank you so much. Got it? OpenBond, I hope my past 10 slides have not been blank page. That'd be great. Let's go back. Okay, so OpenBondX is trying to create a electronic trading venue platform for trading bonds. They do it on an anonymous basis, not because of maybe censorship resistant reasons, but they want to do it because they feel like in the bond markets, who you are, the price you get depends on who you are. And they're trying to eliminate price discrimination in that respect. They do report the trades to what's called the trace system, although there are problems with this loan and bond trade reporting system. It's not exactly real time. They're trying to provide even more transparency on top of that. They have quotes in an auction-like manner. They have these pre-trade risk controls, which are required by SEC regulation. And then you can trade them by hand, or you can sort of have automated trading via a secure fixed connection with OpenBondX. And the last thing I think that kind of comes back to where maybe the most apples to apples comparison, because this is very apples to oranges certainly, but is with electronic reporting. Okay, so there's just a claim made by the company that it mitigates sort of manual reconciliation. Reconciliation is part of that front to back office process. So they're saying that at least you can reduce, maybe even eliminate at some point, and therefore automate straight through processing in that reconciliation process. So the lesson there, maybe the observation, is that blockchains seem to provide value to banking systems, other systems as well, certainly, in terms of the data structure, process, and architecture, hopefully making things faster, more secure, and otherwise. But I think other systems are out there doing that as well. So I think that you really want to think hard about what is the real value that blockchains, non-Bitcoin blockchains, are going to offer. And I think describing that, articulating that, and focusing on that really makes a blockchain-based business sort of the most effective. So that is what I'm ending on. And that is me again, Houman Shadab. And I guess I'm going to be so thanks so much for your time and everything. I guess I have time for questions, or we'll just go straight to the panel. Maybe we'll discuss some of the issues as well.